Lesson 9.2, Video 5, Application of finding the areas or perimeters of composite figures. Let's focus on our first question of a swimming pool. Now we have a request to find the area of the swimming pool below. Now the swimming pool looks like a rectangle, but it's missing a chunk right here, which is a half circle. So to find the area of the swimming pool, we'll find it by doing the finding areas by difference. So in the last questions, we would add shapes together because they're a sum of shapes. This is going to be a subtraction of shapes. So we're going to subtract the half circle. So the area of the rectangle is 20 times 36 minus the area of the half circle, which is pi times radius. This is the diameter, so your radius would be half as long, which would be 9. So it's 9 squared, but it's a half circle, so divide by 2. 20 times 36 is 720. 9 squared times pi divided by 2 is 127.2, which gives us a total area of 592.77 feet squared. Our next question is the area of a deck. Now this area will be found by a sum of shapes, and again you can cut up into different pieces, but I am going to create 3 shapes, 1, 2, and 3. The length of the one piece we're missing here is the length from here to here, which we would find by taking 36 minus 10 minus 20, and that would give us 6. Another missing piece would be this length right here, but that's the same as the height of the other side right here, so that's easy to find. So we have basically a trapezoid, a rectangle, and another trapezoid. And we're going to add those areas together. So the area of the first trapezoid is 1/2. Your height in this case is 6. Right here, that's the right angle. Area of the bases, or the length of the bases added together, so 14 plus 20. We have the rectangle, which is 20 times 20. Then we have our last trapezoid, which now our height is 10, because here's our right angle, times the sum of the bases, which is 20 and 14. And our first shape gives us an area of 102, our second shape an area of 400, and our third shape an area of 170, with a combined area of 672 feet squared. Our last object looks kind of complicated, which is kind of neat because we just have to find the area of the shaded region, but again it looks complicated. But let's look at what we see that's hidden. The whole length is 4 feet long, which means this must be 1, this must be 1, 1, and 1, and so on. This is too high, so again, we're looking basically at circles with a diameter of 1, which means the radius is 0.5, or half of that. The area of a circle is pi r squared, so pi times our radius squared is equal to 0.25 pi, that's 0.5 squared, and there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So we would take that times 8, which would give us 2 pi, or approximately 6.28 feet squared. And this ends Lesson 9.2, Video 5.